Hello, everybody. We are back with another talk. Sarah Ali will be giving this talk. Sarah is the president of the Carleton Computer Science Society. She's also a fourth-year student here at Carleton University. And so, without further ado, just because we do have a short time span here, and I know there's a lot of content to cover, I will pass it right over to Sarah.
Hello, hi everybody. Yeah, so thank you for the intro, Forrest. So yes, this is like Forrest said, this is actually a tech talk that I've done over an hour long previously, and I'm going to make this a lightning edition. So there might be some parts of it that get confusing, but I will be around later during Dev Day for anyone who has any questions, and I will be sharing these slides later. So yeah, without further ado, we can get started. This is an introduction to GraphQL. Cool. I'm a fourth year computer science student, recently just fourth year, and I haven't updated it here on the slide. But Forrest is right. I'm a fourth year, and I am at Carleton University in the algorithm stream. Cool. So the first thing we're going to talk about is the current state, which is REST. So what we're going to be talking about is how REST has been used historically, what's made it so cool, but what's also made it really limiting for developers over a long period of time. So we're just going to be talking about how we currently exchange data across computer systems on the internet. So a lot of you guys will be familiar with REST, get requests, post requests, all that kind of thing. And what we want to do is we fetch data across systems. And an example right here is fetching user data. So for example, we would fetch all users with /API/users. This would be the endpoint that you use. Fetching a specific user, you pass in an ID here, and this is kind of a variable specified by the colon. You pass in the ID and you would get a specific user. And then you can get past orders, for example, here, or you can turn around, you can flip it up a little bit and you can have orders come first and then user ID later. So you switch these two around depending on your use case. And then lastly down here, we can get a specific order. And it's basically down here, there's order ID down here, and then you also have user ID again. So it gets kind of a bit convoluted and crazy the longer and more specific your data gets. So for example, down here, we're trying to get only one user's one order. So that's the more specific you get, the crazier the endpoints get. And that's kind of really confusing and like not really fun for developers to use because they want to use as simple endpoints as possible to get the specific data that they require. So this is where like people started complaining about REST. So exactly, yeah. So like what if we wanted to use the same endpoints? For example, we just want to use users and we want to use users with a specific ID and we want to get everything that we wanted and it's exactly just that and nothing else. So this is why we're limited by REST is because it has fixed data responses. So for example, if we want to return exact data, we can't reuse endpoints before. So for example, if I want to get only one order from a specific user, I can't use this entire endpoint here because it will return every order. So what we want to do is that's called underfetching, and that's an issue we encounter quite a lot in REST, which is why to basically filter this kind of data, the developers on the front end have to actually filter the data that comes in from the server. So instead of having the exact data coming from the server, the front end developers kind of have to deal with that on the client and filter there. So it's not the best way to do it. It's kind of like a bit like you're doing the job of the server should be to return exactly the data that you need, but REST doesn't really maintain that quite well. So another issue that we could have is that we would basically be having a lot of individual API calls if we were having very specific endpoints. So for example, here we have 4 different kinds of endpoints, right? And then that basically has like a lot of you're calling the server so many times for really specific amounts of data. If we want to get 2 different orders, we'd have to call it twice. That's kind of crazy. You're having some serious strain on the server here, and it's basically you can't aggregate those individual API calls, and that's basically called overfetching. Is when you have a lot of extra data coming in that you don't really need, but you have to do it so you can get as few server calls as possible. So that's the current state. Not really great. A lot of you might not even noticed a problem because this is the only way that most people have done it for this whole time. So it's a bit like, okay, this is not an issue. This is just how we do it. But let me show you a better way. Yeah. So what if we could do this? What if we could fetch all the users just like this and we could just specify with the fields that we want? So for example, if we don't need a field, we just remove it from the query. So if I didn't care about name, I just remove it from the query and I'd use the exact same endpoint right here, users, to get what I wanted. So basically what this eliminates is that I don't need another REST endpoint users, which just has a home address instead of names. So it's basically really simple. You kind of just precisely declare what data you want returned. You can also do it the same for specific user. For example, I don't want name, I just have home address. Perfect. I get just that and not extra fields. The front-end developer does not need to have not need to filter the data that comes from the server anymore. Cool. Yeah, you can also get the specific user's past orders. Really simple. You specify in here. So as you can see here, there's a hierarchy. It's like a classes within classes kind of structure. I'll go a bit into it later. This is where the graph comes in. And basically you can see here that the user has orders, and inside the orders, you can specify the fields you want as well. So the specification can go down as deep of layers as you want. So for example, if I didn't want total, I'll remove it. example, from here, I don't want ID anymore. I removed it because I have ID passing in as an input. We get the specific ID. And then a bonus, we can also get everything that we want. So this is the full data relationship, the whole data structure, everything that we wanted, we can have specified at once. Very, very cool. So then what makes it so much better? So like dynamic queries is basically what it's called when you have one specific type and it can return all the fields that you need, or it can return all the specific fields you need as well. So what you need to do is it basically you resolve, it's called resolving. You support two different data types. So one for user and one for order. And these two data types will cover all the information that you require. So think of all the combinations and fields you can dynamically fetch and the inputs and filters you can provide to these queries just to get these two types. So for example, we can have like inputs for ID. You can also have a filter, for example, the products, filter for total, like a total within a range. And what you would have to do is just use the same input, the same query. And you can put in all the inputs and fields that you require. So it's very, very simple. It really reduces the work on the back end because you're only facilitating two types of resolvers. And yeah, so that's kind of like the basics of GraphQL, how it kind of works. And we'll talk about what it actually is. So what is GraphQL? So going deep into it, GraphQL is a graph query language for APIs. It basically provides a complete and understandable description of the data in your API. It gives clients the power to ask for exactly what they need and nothing more. So this is kind of the selling point. This is the buy. You want to get exactly what you want and nothing else. Really, really reduce data duplication, that kind of thing. And it also makes it easier to evolve your APIs over time. So for example, if I wanted to add another field, I could just add it in here. For example, in the front end only, the back end doesn't have to be touched to change those queries, things like that. There's a lot of different hacks as well where you can really, really reduce the amount of evolution that it takes in the API in the future. So really simple. And then also it enables powerful developer tools. For example, GraphQL is self-commenting. We love that. We love self-commenting documentation, that kind of thing. Your documentation is created as soon as you provide a description of your API and your schema. Very simple, very cool. Yeah. So how do you use it? It's database agnostic. So it's basically when people ask, is it front end or back end? It's both. So like for example, you can't say the REST is back end or front end, right? It's like a layer between them. So it's basically an API language. So it specifies the information exchange between the client and the server. It's supported by most languages, tools, and services, not just for React and JavaScript, which is also a misconception. And it can actually coexist with REST. So this is something I want you all to focus on. You don't need to replace everything REST with GraphQL. You can just put it on top. So it can basically be an abstraction for your REST APIs, and you can connect it over the GraphQL server on top. And what people really use this in enterprise to connect microservices together. So for example, you can have 3 different microservices within each other. They already have their REST APIs, but to connect with each other, they use a GraphQL layer on top. And then the GraphQL layer will call the REST calls within each subdomain. So it's very cool. You can put it on top. It's up to you however you want to use it. It doesn't have to replace REST if that's easier for you. Cool. So what does the graph part mean? It's in the name GraphQL. What does it mean? So the idea is that you actually model your data as a graph in a schema. So REST does not really have that kind of functionality where you can actually model data in a really structured way where your users and developers can actually view that. But GraphQL is dependent on this schema. So what it's called is it's basically kind of like if you're familiar with databases, it's very closely tied with your database schema because you'd probably be storing this in storage anyway. But you could also have additional fields in your GraphQL schema that you wouldn't have to have it stored. So basically, it defines different nodes. They're called types and how they connect and relate to each other. So a lot of you are obviously probably familiar with object-oriented programming. So types can reference other types in a graph structure. So for example, I'll show you right here. We have user, and users actually references orders. So as you can see here, this is a type order, an array of orders, for example. And then users also would have, and then queries would also return users. So this is a special type that returns the actual endpoints that we need. And then so then order also returns the user. So instead of having a user ID like we would in a database where we can't store, like multiple relations in the same table, that's where the relationship exists, we could actually in GraphQL get the entire user object when we ask for order. So that makes it really, really, really powerful and how it enables you to get data from every direction. Cool. So multi-directional data, yeah, so this is what I was talking about. So remember when we talked about the different base endpoints in REST, we can switch up the order of the URL, basically the endpoints that you have. So you can have users, orders, or you can have orders, users. So GraphQL kind of innately does that for you because you can actually get it from within each other. So for example, the graph nature is basically designed for that. So you can get the user from an order and all the orders from a user as well because they reference each other, as we can see here. So very similar to object-oriented programming and inheriting classes, that kind of thing. So it's kind of like the same kind of principle, but just applied to APIs now. Cool. So the history. So GraphQL was actually developed at Facebook in 2012. Very, very, very new. Okay, and it was made to overcome weaknesses in REST APIs. So keeping that in mind, this is a technology that was created to cover the gaps. So it's obviously seen as a better alternative because it addresses those issues. And it was made open source only in 2015. So it's very, very, very young. It's now owned by the GraphQL Foundation. So it's open source now. You guys can contribute. You can check it out. And apart from Facebook, it's also being used at quite a number of companies, considering how new it is. Intuit, Coursera, Airbnb, Shopify, GitHub. Shopify quite famously, and a lot of these companies use it as well. A lot of companies will also have it like in some microservices, some teams that are really familiar with it. But these are the companies that actually are part of the contribution on their website, GraphQL website, where they're actually making huge projects in GraphQL. Very cool. So why do you want to use it? So I covered the basics. You can get exactly everything you need. No more underfetching or overfetching. All the queries are dynamic. And what that also means is that you can get all the calls that you need in just one call. So you can make a single query to get everything you need, which optimizes your performance. Do you remember when I had that query where you get all the data in the database or whatever your data structure is in one call? So that's exactly what we're doing here is we can really, really optimize performance. Cool. And then you also benefit from strong data typing. So as you can see, the schema, that's data typing. And it's really, really cool because you have a schema structure and it's created for easy data validation and testing. I love strong typing. Like that makes everything so much easier when you're testing, especially as a full stack developer. You want what you're passing from the back end to be exactly what you're getting from the front end. So data typing really, really, really accommodates and really, really enables that. And I think it's really super cool and it makes development so much easier. I think this is the feature that made me really, really that made it really easy for me to get involved in GraphQL at first, because I feel like without this, I would have really struggled. But for this, it makes it's so easy to enable testing tools and things like that. So very cool. We love that. And it's also scalable. So it's designed to be scalable because that's one of the issues it's trying to address. It's scalable over a microservices architecture. So we basically have a central resource gateway, and this is how you kind of implement different GraphQL servers over a gateway. So the gateway, which is basically like a port, you can call it, what basically takes in calls from all these servers and they kind of interact with each other. So we can get a call from one service to go to another service, and the gateway is going to do that. So what you do is you basically exchange and process data between all of these places, and they can retrieve many resources at once. So for example, in a single call, we can actually ask for data from across different microservices. So just think about the kind of optimization you can do with that, like how beautiful that is. I love it. So, and it's also really great for high-speed development. It's designed for API evolution, like I told you, and it's actually specifically created for rapid product iterations. For example, I want to add a field, I just throw it in the schema, and the front-end developers can add it instantly. That's it. So it's really, really cool. You just resolve new fields, resolve new types, really are able to bridge in gaps between services, things like that. And it auto-generates documentation, which we love. Cool, cool, cool. So what's the catch? Why are we not using it everywhere? Why do we not have GraphQL at school? Why do we not have it at every company that we work at? And the main thing is that there is a learning curve. And this is something quite significant. This is why a lot of people are kind of hesitant to try it out, and why I may have made it kind of my life mission to talk about GraphQL every time someone gives me a chance to. So this is one of the few times I've been done this talk already. But basically, the idea is that GraphQL does have a learning curve. You kind of do need to understand the theory and abstractions that it creates over the architectures and things like that. It did take me quite a bit of time to kind of get used to it, like 3 weeks or so, to really get comfortable getting into it. And I did have help from mentors and things like that. So this is one of the technologies I really recommend joining the community for. And it's open source now, which is really great. And I really recommend, working with other people with, because it's kind of one of those technologies where someone needs to kind of show you how it's done. You can't really go on and do it on your own unless you're super cool, unless you really know what you're doing. But it's helpful to have a community, and I really encourage you guys to rely on it. So yeah, and it also requires libraries for extra features. So for example, Matthew and I actually had a really nice talk about it. Like, when is GraphQL not cool? When is GraphQL kind of weird? It's when you want to do file uploading and web caching. REST actually kind of does that for you quite easily. With GraphQL, you would need to import some libraries for that. But it's okay. I think with these kind of features, you can kind of have those libraries. It's not like it can't be done. It's just not innately in the technology itself. Yeah, and then lastly, it's overkill for small applications. One of the main reasons you don't see it at school, you don't really need it for a school project. You don't even need it for a showcase or a demo or anything like that. Like, you don't need it for really, really small scale architectures. It's actually really, really well used for multiple microservices and an entire infrastructure. That's where you really would, be able to optimize these, these features and all that kind of thing. It's not so well utilized in smaller projects, but I really recommend you guys to still try it for projects. I recently used it for the Shopify project for the backend intern challenge, and obviously it's not the best place to use it. Like, you don't really need GraphQL. I could just use REST, but it's a really cool place to demonstrate features and to practice my skills. So I do recommend for you guys to try it for small applications, even though it's overkill. It's okay. We're just learning, messing around, we're playing around, we're having fun. But like, do remember, like, if you are, pitching an idea for a project, or in a company and things like that, you do have to consider, like, is the complexity and like the overhead and the training and all that, like, and the code base, and all the boilerplate code required, or is it worth it for the complexity you'll be getting when you actually run it? Because it really depends on the cost analysis that you do for that. So think about that. Like, the complexity is non-negligible. So that's kind of an important consideration that managers and developers make when they consider using GraphQL. But yeah, so it's ideal for multiple microservices and ideal for mobile as well, because it's so lightweight. Optimization, we need that in mobile. So very cool. It's very easily used there. Cool. So how can you start using it? So this is the part in my talk where I get a little bit technical, because it's kind of like an introduction and like instructions on how you can start using it. So basically, if this is confusing, I can go over it later in detail for you anytime you want. And it's basically, what I'm trying to say here is, you don't have to burn down your REST API and start over. What we're going to do is actually build a federated GraphQL server in parallel, and we use it to replace the endpoints that you have in REST. So for example, we had /API/users /orders, whatever we want. We just replace those with GraphQL. And we continue to keep using the business logic that we already had in REST. So for example, all those functions that you had to like retrieve data, those database queries, all that stuff, we're going to reuse those. And that's basically, those are called resolvers in GraphQL. So what we're going to do first of all is create a schema. And this is kind of, I love using a schema because it makes everything so much more structured. Before I make my API, I have my schema ready. I know exactly what I want to get. I know exactly what the user needs, the front-end developers and the user need. And it's basically an interface, if you can think of it that way. And it's really helpful. Like, I think it's really a good way to start programming. And you basically create that for your REST API that you already had. You might even see with the schema optimizations you might not have considered before. Because with the rest, we're kind of not using a schema, right? We're kind of just making functions as we go. You might see with your schema, like, hey, I can use this in the same function. I can optimize this. This is redundant. It's a really great way to start programming. So that's pretty cool. And you can also, in your schema, include the data that you wanted from other microservices. So for example, like, I realized that I can actually get this data from another microservice. I put that in my schema. So really cool. And then after your schema, you can start making them real functions. So you start with the developing your resolver functions, and you can get all your queries and fields. And this is like basically recycling the code you already had. So it already exists in your REST API. You just kind of use that controller logic all over again, and you extend your data from other microservices. So for example, if I wanted to get price points from another service, I would write here in my resolver function that I'm getting it from another service through the gateway. So that's really cool. So this is kind of the main chunk of the work already done. Now we create a service. So service is basically the endpoints. So as before, I showed you the queries where you have, like the schema, you have like, get, instead of having a get request, you kind of just make a query user get this ID, that kind of thing. Very simple. This is kind of like really simple part of the code. You kind of can copy paste this, just make the queries, really simple. And then you can include your service in the existing federated GraphQL gateway. So this step is kind of optional. It's only required when you're connecting to an existing GraphQL infrastructure. For most of you guys' projects, you're not really doing that. You're kind of making your own standalone service. You don't really need to do this. But if you are connecting to an infrastructure, you kind of just include that service inside the gateway. And then you can run the gateway and ask for what you need. If we don't have a gateway, we just run the GraphQL server ourselves locally, and we can ask for what we need. And then basically the front-end developers will use those queries, same as with REST, use those queries to get the data that they need. So it's pretty cool. Yeah, and then some useful resources, and I'll be sharing the slides later. So it's really awesome, honestly. Like, I really enjoy it. And I would usually have a code demo a little bit here in my usual hour-long tech talk, because I would have more time. And I know that I may have rushed through a lot of things because I was trying to fit all the content that we have. So please feel free to take this time to ask me questions and anything that I skipped over that you didn't understand, because I'm well aware that I went really quickly.
Awesome. Thank you so much, Sarah. It's really cool to kind of see this discussion on GraphQL, a little bit about the background, a bit where it's used and stuff like that. A few questions that I am seeing in chat. And so first of all, you did describe like the object-oriented nature of GraphQL. And so can you go over again, just like a little bit about the inheritance pattern that it has and how it actually compares a little bit to object-oriented?
Yes, for sure, for sure. So like, as you guys are aware of, in object-oriented programming, we have something called diamond inheritance, when we're inheriting from the same kind of base class, but we're separate, and then we're kind of connecting later on. So can be done in GraphQL as well. So for example, they reference each other. User and order reference each other. So order has, an array of orders. So don't be confused by the fact that this is an array. It's still referencing the type order. Same here, we're having order reference user, and this doesn't create complexity. This doesn't create like a deadlock or like an issue or like like a circle reference. GraphQL is actually designed for just this. So for example, when we go down here, the reason for this is when we actually make queries like this, query users ID, orders ID, with all this stuff, we could actually be enabling it to actually run it the other way around. So for example, I could have query orders, and then this would have everything, and users in here, and then user ID, name, home address. So you can do it in multiple directions. And the more layers that you have, the many directions you can do it. And the cool thing about this is that developers, backend developers, don't necessarily have to create um, they don't necessarily have to enable this kind of query, because the reason to do this would be when you actually have let me go back to the schema, when you actually have schemas referencing each other. So this is not a requirement in GraphQL, but as developers, we like to enable this so that when front-end developers need something like, hey, I'm on this page, I'm on the orders page, but I want to go to user, but I don't want to reset my, query. I don't want to go back, back to the front page. I don't want to do this. I want to get it from the same function. I want to get it there. So that really enables these kind of like requests that they might have in the future. This is why it really enables API evolution, is you can get it in no matter how far deep you are in your query results, no matter how far deep you are in your levels and nests. When you go down to it, you can still get information from up above if you want it. You just have to ask for it. So does that help a
Awesome.
little bit?
Yeah,
Explain the object-oriented part of it? Yeah, the graph
yeah.
structure? Yeah.
Well, I think when we think of graph structures and when we think of like object oriented and sort of like inheritance and stuff like that, one interesting thing that I sort of didn't think of up until this point that you mentioned was the idea that when we're calling stuff from a REST API, I mean, whatever you send back on the REST API can be whatever you want from the backend. However,
Mhm.
I don't often think very much in combining types of data, but you described here that you're able to like combine stuff from different tables, different row or different columns and stuff like that. So that's like, I mean, also when we think of like inheritance or at least like sibling levels of objects and stuff like that is kind of all in that same vein, I think.
Exactly. So for an example, if we're doing REST, so we usually have like get users, get orders as two different requests basically. But with this, we could do it all at once. We could get one user, we can get one order, we can get like the one price point. We can go as specific to the field level if we wanted, and we would just have to use the
Mhm.
same endpoint. So it
Yeah,
really, like when you get to really complex, programs and applications, usually for web apps, we want to display all the products, right? But if we're going to something like in the data science level where you want to get specific fields only, this is where GraphQL comes in really handy, because you don't have to make those specific by attribute REST API requests. Yeah,
exactly. Yeah.
exactly. Yeah.
Um, Now, something I'm wondering a little bit about. I believe you worked with GraphQL in one of your previous jobs. So what I'm wondering is, can you tell us a little bit about the use case that you used it in? If not, like not sharing like too much that you're NDA'd behind or whatever, but kind of share a little bit about that.
Yeah, no, for sure. So like I will say that like I came into a team and they started building their GraphQL server. So I came in on the really early stages. I was actually the main person writing the resolvers and testing them. So I was able to really see the GraphQL being built, the server being built. So what we use it for is basically I worked at Essence. It's basically a fashion luxury retailer, e-commerce brand, and they have all their products online. And what my team was doing was basically collecting product metrics for them to be able to later on recommend to buyers which products they should buy, because we wanted to make data-driven decisions when they collect new stock. So, for example, the kind of fields we'd want to give to buyers would be like, product turnover, product profit, things like that. Like very minute kind of accounting metrics. And the reason we chose GraphQL is because we were returning 60 product attributes at once for thousands of products since the company's inception. And for that with REST is just really painful. So it really helped us to have a really aggregated and optimized server where we can collect all the data at once and do data science on it. So that's why we used it. And I think it worked out really well because we never had any performance issues, never had any optimization issues, things like that. And it was just really cool and really well maintained with the Steam schema. I feel like the schema made our project so much simpler because you could see exactly what you wanted. Otherwise, dealing with 60 attributes for a single product over thousands of products and users is not fun. So I think it was a really
Yeah.
great use case. Yeah.
Awesome. Yeah, that's super cool to hear because I think when we go through like a lot of the theory on GraphQL, it's difficult to take this understanding and sort of wrap our heads around like where it's used in the real world, especially in like
Yes.
medium-sized projects. So
Yes.
that's super cool to hear. Sort of like, yeah, if you're talking like 60 attributes on,
Yes. Exactly.
like you're pulling that in, then yeah, that's a ton of data to deal with.
Exactly. So the
Um,
more data you have and the more minute it gets, it's a much more worth it. Yeah.
yes, exactly. So I think that's about it for questions. Oh, actually, sorry, there is one more here. Right here. Um, so do you think that GraphQL could eventually replace the need for REST altogether, or are there cases where GraphQL can't accomplish the same thing as REST?
So I love that question. I love that question. So even though GraphQL was designed with like, the limitations of REST in mind, it was literally created for that. I don't think it will replace REST, and I don't think it has to, because it's like like Forth and I were just discussing. It makes sense for really intense, really complex data structures and complex data relationships. But for other really low key, like for example, like when you talk about like static web applications, you just want to return, like, you don't even have like authentication or authorization. You just want to return like products on a page, or you want to return like a list of like list of items. For that, REST is perfectly fine. Just get all your items, post all your items. You can even make a really simple web application where it's like a bookstore or something like that with user logins and registration. That can still be done really well in REST. It's only when it gets really, really complex and you're dealing with different microservices and infrastructures, different entire database schemas, where GraphQL would be a huge help. But I think I don't see most of the internet converting to GraphQL, like even in my mind hypothetically, because it's not required. Like that kind of complexity, that kind of overhead, and that kind of those kind of optimizations for most websites, they're not required. So I think the rest is still really, really great. I love it. It's just not. It just doesn't. It just gets really, really confusing the more detailed you get with it.
Awesome. Well, thank you so much, Sarah, for the talk. This was a really great one, and I think I've heard you give a talk about GraphQL before, and for myself, this solidified a lot more ideas that weren't necessarily as clear the first time. So
Oh,
hopefully, I
awesome.
can come back with a cool story on how I'm making use of it myself sometime.
Yes, yeah, I'd love to talk to you about that. And for you guys too, definitely like reach out to me if you start working on GraphQL. I also have a couple projects that are private, but I can like share them with you. But let me know. I would love for you guys to play around with this technology because it has become quite a buzzword in the industry now, and I think it's warranted. I don't think of it as like something that has a hype, like a trend or anything. I think it's a definitely a very very cool and promising technology that's kind of taking over bigger infrastructures. So I do want to see you guys, getting some experience in it, so you can talk about it in your interviews, things like that. So yeah, good luck.
Perfect. So we'll be back in about an hour with our next talk. But until then, we have a social break. And so if you want, we have a Discord channel set up for that. So feel free to join that over the next hour. And we will see you then.
Bye.